Hello everyone, and thank you for joining another Foreman community demo. I'm Nafar, I'm an active developer within the Foreman project, and I'll be hosting the demo today. As usual, we have some updates to share with you and some new things we've been working on to share with you as well. So for any questions or comments, feel free to reach out to us at the Foreman group chat on Metrics, or during the demo, you can also use the Google chat here. Okay, let's have a quick look at the agenda for today's demo. So we have 6 topics in total, and the last two of them are developer-focused demos. Okay, yeah, that's it. That was all for me. So we can go ahead and start the demo. The first one is from Maria, our UX designer, with RFC, the new task details page.
Thank you very much, Nofar. So let me share my screen right away. Hopefully I will not have any internet connection problems. So this is a proposal for the new task detail page. Here you can see the repetition of the name, but these are breadcrumbs where you can go back to a task index page. This is the name of the random task. What we have here is that we are not using detail tab anymore, but we have details here on top part. I also took a couple of details from, for example, raw tab, such as external ID, duration. Also, what we have, so before that we used to have like 5 different buttons next to the task. Right now we have just cancel and dim flow console. More of them are hidden in the kebab. Feel free to comment on that. What I did here was I basically took, what was that? There was running steps tab and error tab, and I merged them together. So right now, when the task is when the task has stopped, we have basically what would we have in the error tab. So right now you can see this task ended with an error. You can see error. We have the huge notification here. And also you can scroll down to see more about like exception or backtrace and so on. So this is not a fixed length of the exception or backtrace. Like you will see all the text right away. So the length is not strict. So what else we have here? So this is how stopped one would look like with the warning. Again, everything's yellow. I think this is like right away. You see, even without a red loading bar, that something bad happened since it's red. Something not great happened since it's yellow. Now also you can expand this, view more. So this is how it would look like if everything went well. So again, I'm not using the loading bar, the progress bar, but you see there are no error found. So this is an example when task is still in progress, but is not progressing since some steps are temporarily suspended. Users can't do anything, basically just wait, but it's some kind of information. And here I am using this bar, so you know something is happening. We already have that kind of state in current implementation, but basically without any text. If you have ideas what I can write to this inline alert, feel free to tell me to write me in my RFC that is linked to this demo. I'll be happy to read it. What's more, this is a running state. And this was all for execution details. So you would see running steps here, running steps here. This is the part of running steps tab. So what else we have? Okay, I'm so sorry, this is incorrect. This should be on logs. So now you see redesign logs tab, if you have any. So there are non-exclusive resources and exclusive resources. Right now in current implementation, we don't use a lot of explanation, or we do have some, but it's an alert for some reason. What's important here, I'm looking for people that are actually using logs or find it somehow valuable. So again, feel free to drop your feedback in the chat or in the community demo section comments. So this is if you have any logs, this is if you don't have any logs presented. The top part would be the same. We added dependencies recently. I still need to find out more about that because I just realized we have that. So that's all from me. Feel free to give me some feedback. Some people already did it, and I'm really happy from what I heard and read. So thank you.
Thank you, Maria. It looks great, and I hope you get all the feedback you need. Okay, I don't see any questions. Yeah, so we can move on to our next topic from Lars about contributions from the community.
All right, I'll try to share my current presentation. Start slideshow. Oh yes, so hello everyone. Today I'm going to present some community contributions that will be released in Foreman 3.18. So yeah, let's start with Foreman KubeVirt. Yes, major changes in KubeVirt compute resource. We released new Foreman KubeVirt version 0.5 and also new Fog KubeVirt. Basically quite a lot of bug fixes, including some of the security stuff. And we are right now aiming on the image-based installation. So for anyone interested in this is released in 3.18. I'm right now working on article on how to set up Minikube with Foreman. I hope that next week or sooner it will be released. So it will be super easy to provision machines with this kind of setup. So give it a try. And if you find any bugs, ping me and we'll take a look at it. The other stuff that is from the Fujitsu team from Japan, they did quite a lot of work on BMC improvements in Smart Proxy and in the Foreman. I made a list here, so I'll just go from the top. The most recent change is the support for the ETAG header for the redfish operations. Improved resolving FQDN to IP for the SSH API. So right now, like in previous versions, we used only IP address. So with Foreman 3.18, finally the full FQDN is used for the resolution. We have a BMC developer documentation. I forgot to write that it's in the Smart Proxy repository. So there is some instructions on how to set up on the dev environment and play with the BMC. and improved and added new supports for operations like reboot and reset, and improved the power operation for the Redfish provider. That's all thanks to Fujitsu team. And my last stuff, yes, ATIX team, this time from Germany, is working on improving for the Foreman boot disk and vSphere integration. The latest update is allowing rebuilds only if the host is powered off. This feature is right now implemented just for Foreman boot disk, but it's basically available for any compute resource. With this change, you can say configure specific provisioning method to be allowed for rebuild only when the host machine is powered off. The reason why we introduced this feature is that sometimes between the rebuild and uploading the ISO to vSphere, it can happen quite a lot of stuff, and the host ended in the wrong state, or the ISO has not been correctly rebuilt and uploaded. So with this change, we are making sure that before you rebuild the host, you have to power it off, then run the rebuild, upload the ISO, and it works better and it's more predictable. With that, we also have some upcoming changes for the Foreman boot disk. We want to definitely further improve the vSphere integrations. PRs are already open, so I hope I'll look at them as soon as possible. And also, a draft PR where there is a support for libvirt in Foreman boot disk. So the same functionality that we have right now for vSphere, we'll maybe have for the libvirt as well. So yeah, that I know it was quick, but that's something that I wanted to definitely share with the community. Again, thanks to ATIX, thanks to Fujitsu team, and yeah, hope we'll get much more contributions from them as well. Thank you.
Thank you, Elias, and definitely thank you for all the contributions. Yeah, we can move on to our next topic from Ian. Ian, whenever you're ready.
Sounds good. Share my screen. Okay. So let's see. What I'll be sharing today is what started as a bug report and turned into a nice feature spanning a few plugins. So the initial bug report that caused us to work on this composite content view auto-publish chaining was that sometimes if you're using composite content views with Catello, you may sync a bunch of, or sorry, you may be publishing a bunch of your content views, but then one of them finishes, triggers an auto-publish of the composite while one of its children are still publishing. And what you often end up with is your composite content view publish will go into a pause state. It may complain that maybe there's a publication and pulp missing. All sorts of strange things can happen because the publish happened, but the child content view was not ready yet. Now, this is a difficult case, and we hadn't solved it for a while because the auto-publish is completely like a separate Dynflow action chain from the main ones. It's just a task that's triggered by another task. And previously, we didn't have a way to link these tasks together. And so Adam, who works a lot on the Foreman tasks work, the Dynflow stuff, he put out a PR a while ago, a POC of allowing you to chain separate executions in Dynflow together. And so I ended up taking that and building it into this feature with Catello, where now if a composite content view publish gets triggered, it will be scheduled using this new chaining method from Dynflow, and it will wait for its children to finish publishing. At the same time, a previous full-time Catello developer, Jay Terrell, you might have seen him in the community or on GitHub. he also was working on getting rid of the composite content view auto-publish, the use of the Catello event queue, which did some kind of weird polling, and it was replaced with like a hook-related solution with execution hooks. And it's been a much more robust solution, and it made the work a lot easier to get this chaining working in Catello. So it's been a big effort with a bunch of different people. So Catello is now updated to chain these tasks. Dynflow has been updated to support chaining, and Foreman tasks has also been supported. Now supports exposing that API from Dynflow to do the chaining, and also showing dependencies. And so with that all out of the way, let me show you what this looks like. So my content view page is up. I have a few content views here. So I have this this rel container zoo composite. I have a rel 10 view, and then this zoo one, and these are all in the composite. So this rel 10 view is a slow publishing child. The zoo view is a quick publishing child, and then this is the composite. So what I'll do is I'll kick off the rel 10 view while it's publishing. I kick off the zoo view. It will finish, trigger an auto publish, and you'll see that now it's going to be scheduled instead of run directly. So we'll run this new version, this new publish. So this guy is now publishing. Now I go to this one. This one publishes essentially instantaneously. And now we go over to tasks. We refresh. So there's this publish task here. The name isn't completely filled out yet because it's scheduled and it has something to do with how the naming works in Foreman tasks. But you can see it's in a scheduled state. Now what's cool is, and Maria mentioned the dependencies tab before, now you can click on this dependencies tab and you can see what it depends on. So this publish depends on the rel 10 view that's taking a long time. And once this finishes, you'll see this task will turn into a normal task. It'll run through its whole courses, and you'll see that the dependency is still here. And I actually did this earlier. So you can see now that this publish task will turn into an auto publish, and the dependencies will stay. So you can view now what kind of dependency situation you had before in case you're debugging, or you're just curious what's going on. And if we go into the dependent task, we can go over to the dependencies tab here. And we can see it blocks the scheduled publish. So both sides of it works. So since this is such a big change, yeah, we'd love to see people help test this out on nightly. Originally, I was wondering if this could be backported into 4.20, but since it requires very new Foreman tasks, that's not possible. And also, we wouldn't want to destabilize 4.20 anyway at this point. So yeah, Catello 4.21 is the target, and it's currently in nightly. So yeah, please give it a try, and yeah, let me know if you have any issues. That is all.
Thanks, Ian. I hope you get the feedback you need to. Yeah, let's move on. Next one is Chris with Azure and Foreman.
All right, let me go ahead and share my screen here. I'll try to keep this quick because that's a huge topic in general. So let me see. All right, so I've got, I'll show the Foreman side of things first, and then I'll do a little presentation, and then I'll show the Azure side of things. So the appeal of this is really because I'm not seeing that much use in the Azure plugin, and I don't know if the community is aware of it or if it's just too complicated to use. So I wanted to show how it works in Foreman and kind of explain like why Azure is the way it is compared to AWS. So what I have here is just a few hosts that I've made but I want to show the Foreman side of things first. And we'll kick off a host build, and then we'll go to the presentation, and that should be finished by the time it does. I don't want to have you guys just sit here and watch the spinner go for like 10, 15 minutes. So, so to add a Azure compute resource, you need a couple things, and we'll talk about these in the presentation. So we have, you want to pick which version of cloud you're going to use. So there's a client ID, which I'll cover in the presentation what that is. There's a secret, there's a subscription, and a tenant ID. And then once you have that, you can pick your region then. I'll show you this one. So you can pick your different region. The next thing we need is Foreman uses finishing templates to go out and provision those images. And so what we have here, you can see my machines. And then we have some images. We're going to provision a Rocky image. And so I just wanted to demo that. So kind of, we have an image, and I'll go ahead and create the host here so you can see that as well. And then I'll kind of explain everything. And I think once you see like the presentation, it will make a little bit more sense. So we're going to, it's normal process, just like you would build any host. I have a host group set up here. Just takes a moment. The machine it's running on doesn't have old school disk. So a virtual machine. I've got my size here, my resource group. I'll explain what that is here in kind of a second. My username and password. Typically you want to do SSH key, but just for the sake of the demo, I'm going to add one disk to it. Some VMs actually don't need a disk. Some VMs do need a disk. If you don't put a disk in, you'll see it kind of blow up and say, hey, it needs a disk. This one just needs a disk. Doesn't matter the size, as an extra disk. Let me go to operating system. If you notice, we use image-based provisioning. One thing here, though, to know is that the root password isn't needed, because if we go back to our virtual machine, we're going to be using this password, username and password, or the SSH key if we're going to do it. And so I have my finishing template. Same thing for interfaces. When you know, like if you're provisioning in Foreman normally, you would have an IPv4 subnet. That doesn't make a difference here. You don't need it because we have an IPv subnet in Azure. I'm going to take a public IP address so we can actually SSH into this VM. So you can do static or dynamic. I'm just going to do dynamic. And the rest of this stuff I'm not using, so I'm going to go ahead and hit submit. That's going to take a little bit. So let me go ahead and present the presentation or the slides here real quick. Let's see. All right. So hopefully you can see the slides here. So how is Azure organized? Like if you've used AWS before, it's kind of really simple. When I was working on the cloud billing, AWS, I was able to spin up an instance in like a couple of minutes. Azure took a little bit more to get set up. So how is Azure organized? We have the Active Directory. So when you create an account on Azure, you are bound to an Active Directory, or Entra ID now they call it. And that's your tenant ID, where we get that tenant ID from. And I'll show some pictures here which kind of make this look a little bit better. So then we have a management group. So inside of that, by default, there's a group, but you can have different groups, and those are kind of like your rules of, hey, this group is only allowed to deploy instances in the East US and so forth. And then there's the subscription piece, which is the next layer down. And so that's our subscription ID that we're going to grab. And that defines, how many VMs I'm allowed to build. There's quotas you can set, so you're not spending $1 million a month on something, etc. And then there's resource groups. You probably saw that when I was creating the host. That is basically a folder or a container of resources. And that kind of brings me down to the next piece. The resources are everything: virtual machines, hard drives, network interfaces, public IPs, databases, Kubernetes, containers, whatever you want to build will go into is the resource. And that goes into the resource group. And so I've kind of made this, because I'll share this out, it's kind of like the dummy way of looking at it. It's like, okay, what is each one? Who can log in? What are the rules? Who pays for it? What belongs together, etc. So I just kind of make like a little cheat sheet table of what it does. So the next thing that we need is permissions. So there's probably, I think last time I looked, there's 82 different roles on Azure for permissions. There's also ones that give you full access to everything, like the global administrator. These permissions, I believe they're documented, but these are the 4 that we actually need to actually build machines in Azure if you don't want to give your access to the whole world. So like virtual machine, be able to create virtual machines, network, be able to create networks, be able to manage disks and stuff, and to be able to read that subscription and see what those resources look like. So when we build that VM that's building right now, how does that actually, what does that look like behind the scenes? So I kind of like found this cool little high level overview. So we have the internet, we have, remember our resource group contains everything. We have the public IP address that sits inside of that resource group. We have the virtual network that sits inside of there. We have the NIC for that, and then the VM itself. The network security group, if you're familiar with like OpenStack, it's a software firewall, so that controls the inbound and outbound connection or rules for ports besides the one that you set on the VM. So that's that NSG over there. And then we have the disks, etc., and then we have logs. So any hypervisor like VMware, OpenShift container or OpenShift virtualization, etc., all those have logs that you can look at if a machine's not working, etc. So some common permissions, some troubleshooting things. When I used to work with this with customers, I would say 80% of the issue is permissions. Like basically either it's like a super admin that gives their user access and it doesn't have the right access to the subscription, or doesn't have the right access to the resource group, etc. Some subscriptions, I found this a while back with a customer. If you're trying to, some subscriptions don't allow you to deploy like multiple like 1 terabyte machines, etc. So those are something as well that can be hit. The other thing that I saw when working with customers on this is, I filed some RFEs, or I have some I need to file, but the UUID screen in Foreman, it's really not very intuitive of how you make the UUID. If you don't put a UUID in correctly, we refresh the page and we just tell you it's invalid. So I've found some different ways looking at the code that we can enhance that to kind of do almost like, if you're familiar with Catello, like a repo discovery. But there's a marketplace, and this Rocky one we're going to deploy today is out of the marketplace. And you see we have, if you look at it, and I'll show you in Azure what it looks like too, but we have a publisher ID, a product ID, and a plan ID. So we're going to deploy Rocky 9, and so then our URL would be constructed as marketplace, publisher ID, product ID, and plan ID. And then if you don't want to use latest, there's like ways you can find that out in the UI. You can also use the Azure shell and to see it too. Now, some of the other issues that I've seen with VMs is that if you try to deploy it in Foreman, it'll sit there for like 5-10 minutes and then fail back. And a lot of images I've noticed need to have the terms and conditions accepted. And unfortunately, that can be done. If you do it through the UI in Azure, it works just fine. But if you're using an app like Foreman, we have to go in and accept it through the Azure shells, or through the Azure shell. So I've put that command there, but we shouldn't have to. I've already accepted it, so it should work fine. And I don't have my images, so let me go back while we're doing this. Sorry. Let me share something. Give me 1 second here. I thought I had those images put in there. I swear I did yesterday. So I can just share real quick what they look like. Give me a second. Sorry about that.
Okay, Chris, don't worry. Yeah, I agree.
I know. I don't know what happened. I'm so sorry about that.
And we were just saying we like the Foreman image with Azure.
Oh yeah. The Foreman guy, yeah. I'll put that
Yeah.
in here.
Is it AI generated?
It is AI generated, yes.
Okay, it looks like it.
Um,
Good use
okay.
of AI.
So let me go ahead and so this is one of the images. I don't know why they didn't make it in the slides. That was my fault. I was doing this late last night too, so I kind of messed up. But remember how we talked about the directory? So there's a this is like a single use. So like this is my account, how my account will look. We have an Active Directory. We have a management group that contains a subscription. That subscription then contains a resource group, and then we have the resources. So let me show you what one looks like that is much larger. How most larger customers have it, and then we'll get back to the demo. So this is how most customers have it. So you have the Active Directory, you have the root group. So if you're familiar with Windows at all, inside of Active Directory, you can have Forest, or you can split that into groups. For example, like at Red Hat, there's I know accounting and payroll uses Windows. I'm sure they're not in the same group. So you'd have accounting. Accounting would have their own special tree of different groups and users. Payroll would have their own. And then you can see that those are allocated to different subscriptions. So the people over here can't have access to this. Those have their own resource groups. Each resource group has their own VM. So that's kind of how you isolate it at a larger scale. So let me go back and we'll check on our VM here. Let me go back, and then I'll put the Foreman guy up so you guys can see it again. All right. Can you see it okay, or did it flip over yet?
No, you're sharing the wrong tab.
Oh yeah, there we go.
Okay. I don't know, maybe try to switch between tabs. We see the Google Meet. I don't know what to call it.
Yeah, no, let me just try sharing and then share again. Let's see.
Yeah.
Now, no. All right, there you go. Can you see it now?
Yeah.
Okay, so you see that host has built. We have a public IP address. We can SSH to it. You can try it while I'm showing you the difference, the Azure side of things. So let me go to the Azure side of things and show you what that looks like. So inside the Azure portal, it looks very different, obviously, than AWS. So what we have here is I'm going to show you how that works, how that looks from the Azure side broken down. So we have the Azure ID, which is, like I said, your tenant ID. We have that right here that we can get. That's how we get that first piece of information. And then the second thing is so how Azure works, or with Foreman, is so you have users and groups, but Foreman is a app, and that creates a service principal. So it falls under this thing called app registrations. When we create an app registration, we get a client ID. And what that does is that creates a service principal within Azure that you will have for, and that is where that role comes into place. We have, instead of a user, we have a client ID, and we have a tenant ID. So that's where we get our client ID now. Now, where we get our client secret is if we go to secrets here, we just do a new secret. We get our client secret now, so that's where we get our secret. So that's kind of, and then the next thing is, remember, we have subscriptions. So our subscriptions here are created underneath the Active Directory. I should be saying Entra ID. That's what they call it now. But so we have our subscription ID here. So you can create different subscriptions. You can set resource quotas, etc. on them. So I went ahead and used this one. So now what we have is we have our resource groups. That's the next layer of this. A resource group, I just called it personal for the sake of testing. And inside of our resource group, let me move this over. But yeah, so we have, so one of the things I hate about Azure too, like you can't reposition the screen stuff. So what inside of my resource group, I have some images, I have the network interfaces, public IP address, the virtual machines, the disks, etc. So one of the things you can also do with Azure, like I said, so if we provisioned a Rocky Linux from the marketplace, so you can actually have your own images as well. So if we go to Azure Compute Galleries, one of the URLs that you saw in my Foreman was gallery. So if I go back to it here, and I go to images, so you can see the URL is gallery now instead of marketplace. So it's templates rel v2. How that equates in Azure is I have a image gallery, and inside of that is a template or my image gallery or my gallery type. And then I have image definitions. And if you're familiar with like Catello, these are kind of like content views of machines. So that rel v2 is right here. If I go to that, this is a 0.0.1 version. So what you're doing is, it's kind of, I like to explain to people like content views. You take a machine off the marketplace, you build it, you change it however you want, and then you put it in this image definition. And then you can deploy from these. And then say like you wanted to update Apache. Well, you would deploy, update Apache, create a new version, 0.0.2 or whatever you want to version it. Now you have a new image that you can deploy. So it's kind of like content views for virtual machines, I guess is the easiest way to explain that. And then we have our virtual machines here. So we see the one that we made. The one that we created was Janet. So let's take a look at Janet. So we can see that it's running. We have a public IP address that we can hit. You can see information about the virtual machine, etc. So, and that was, I think, it. I'll show real quick the Foreman guy again, just for fun, but. So, sorry, the slides, the things didn't go in there. I swear I had them in there yesterday. I don't know what happened, but that's all I had. Hopefully that kind of cleared up Azure a little bit.
Yeah, thank you, Chris. It most certainly explains Azure together with Foreman. Thank you for the great demo. Yeah, I guess we can move on to the next. Actually, it's the next part of the demo. Now we're moving to two developer-focused demos, and the first one is from Maria. So Maria, whenever you're ready.
Hello, I'm going to share my screen, and it's just going to be the post, basically. Yeah, we've been, I think someone is not muted. Thank you. I think, okay, we've been on this way for a while now. I just wanted to make things a bit more official and just lay out the plan that we have and let people know what direction we're going on. Shim wrote a great post about some of our UI infrastructure struggles that we have. And we just use a lot of different technologies, and it looks mixed up. And also it's hard to, like, if you know React and then you have to go and read Angular code and maybe fix it, that could be a bit difficult because people usually focus on one tech. So just to remind people, we have UI coding standards. Basically, it's in the handbook, which outlines how to contribute to Foreman, and we have developer docs. If you find something or some information is missing or not clear, please let us know, and we will be happy to add it or fix it or clarify. Yeah, so basically, all new UI codes should use React and PatternFly. Specifically, right now it's PatternFly version 5. And we should be testing those with React testing library and Capybara, which is what we're doing now with our new components, but if somebody wants to help out or write their own plugin, we ask to use these specifics. And we try to reuse PatternFly as much as possible. So we try to reuse their components. And we try not to make anything too new. And if for some reason there should be like a new component, like the PatternFly team, they have their own community, and you can ask there if something should be, if you want like a new component, you can ask like, should this be a new component or can I reuse something? Maybe they will find a solution. They're very helpful. Yeah, so right now our plan is that we want to update PatternFly 5 to PatternFly 6. PatternFly 6 does not support our React version, and Enzyme is what we use for tests to do half our tests in Foreman plugins, does not support React 17 and up. So we need to update all of our Enzyme tests. Usually these will be tests like snapshots, but usually it's the render function from Enzyme is what we use. And we're looking to update it to React testing library. And this is a small reminder that we updated how we test things. So all tests will be run from Foreman core, and you no longer need to mock components from Foreman core because the test should just take them directly from Foreman. You can still mock them if you want, but you don't have to anymore. And then the next step for us would be updating PatternFly 3 components to PatternFly 5. We're slowly moving through all the PS3 code and migrating it, either refactoring or doing a redesign. For example, you saw Maria's redesign for the tasks. We're also on the way, like if we touch the code in PatternFly 3, we will also try to update the tests. So this would be like kind of a joint effort of PatternFly 3 and enzyme removal. And once we have these two, we can update our React version, specifically once enzyme is removed. I don't think I saw any issues with updating the React version. I think it's mostly just enzyme usage. And once we get all of these parts, we can upgrade to PatternFly 6. PatternFly 6 has some automation to run on the code that we have. It's very useful, so maybe we'll do it all at once, like we did from PatternFly 5 to from PatternFly 4 to 5, but it should not be as difficult as updating from PatternFly 3. And this is like future hopes and plans, is that we hope to remove all the ERBs or the server-side rendering pages. We don't have a concrete plan on how to approach it because we know that there's a lot of helpers that could be moved to React first, and then we can use them in this refactor. And we have some pages that we want to redesign. So this plan is still work in progress. We're not sure how we're going to do that. We just know that we want to remove it, and we're definitely not adding new ERBs. And as well, we have some Angular pages in Catello, and we will refactor or redesign them. So also, please don't add any Angular components. I think this is a summary. This is just to let people know where we're going. And if you have any like standard questions or how to do questions, please ask in this topic on the forum. Thank you.
Thank you, Maria. Yeah, looks like we have a lot of work, so thank you for taking care of all of it. And yeah, we can move on to our last topic of the day, also a Foreman developer focused, exposing features in Foreman CTL. Evgeni, whenever you're ready.
Hi, thanks. Let me share and see how far that explodes. There we go. Okay, so what I wanted to talk today about is Foreman control and how it can deploy more than a pretty empty Catello machine. If you ever like tried Catello Foreman control already, you have seen that it does deploy Catello with Foreman remote execution, Foreman tasks plugin enabled, but Foreman remote execution actually doesn't work. It's like pulled in because it's a dependency of Catello, but you cannot actually schedule any remote execution jobs because on the proxy side, we do not have any proxy deployed that would actually have the script feature enabled. And Adam was very sad about this, so we are going to fix it now. But before we can do anything about it, we need to have a way to actually define what is a feature and what a user can enable or disable in their environment. And to do so, we came up with the idea that we want to diverge from how Foreman installer worked. Foreman installer was very Puppet-based, and it would expose everything that was in Puppet. It would directly throw that into the user's face. So you know that if you run Foreman installer --help, you would get pages and pages of output because you could change so many things that were in Puppet. In reality, most of those never were touched, and we decided that we want to go for a more explicit way of doing things. So only things that are explicitly marked or described as being shown to the user will be. And one of those things are features. So what we are doing is we have a YAML file that describes features of our Foreman control, what our Foreman control is capable of deploying. So anything that is not listed in this features definition just doesn't exist. So we start with basic things like Foreman and Foreman proxy, because obviously it's also the basic building blocks that you need. And then on top of them, you will get things like Catello, which you already have seen, right? Because that's the default feature we're deploying right now. But we also already define features for Google and Azure so that people can go and enable those and talk to the relevant compute resources, or, well, clouds in this case, right? But those all are Foreman plugins as we know them. But what it comes now to the whole scenario is we also need a Foreman proxy, and a Foreman proxy with the remote execution plugin installed there. For that, I have a large-ish PR that does many things to Foreman control that I'd rather skip for now because they are way under the hood, and you shouldn't have to touch them at all whenever you expose a new feature. So I will open only up the main patch out of this PR. That is, the whole PR is 250 lines, so it's not huge, but still also not minimal. And this is the one commit out of it that introduces remote execution as a real feature. And if we scroll down for a second, the first thing obviously is we added features.yaml and add remote execution. And to make things slightly more exciting, remote execution requires Dynflow. And while things get enabled nicely automatically on Foreman itself, on the smart proxy, we need to go and enable Dynflow manually or semi-manually, I would say, because that needs enablement in the configuration file that would otherwise not be happening. So what we're now doing is we define a feature, remote execution. We tell it what Foreman plugin it would be using, but it's not that important because that's already installed, right? But we're also telling it what the plugin name for the proxy is, and we tell it has a dependency. The rest is then handled by Foreman control for us, and also the dependency resolution, and then enabling the dependent Foreman plugin. So this is like all that you would need for the exposure to the user. So I'll just jump to my command line and show you that we have this add feature command. And if I now go Foreman control, deploy, oh, no, deploy, -- add feature Foreman proxy, -- add feature remote execution. This will now do two things. One thing is it will enable the base feature Foreman proxy, because I didn't have one. If you looked closely, the proxy that I have here is the pulp one. And it only has like pulp core feature enabled because it's running inside the pulp process. It has no smart proxy process at all yet. And the other part is we are enabling remote execution because that's the actual feature we care about. So, and if we are going to run this, takes a moment so I can talk while things are working. What it will do now is obviously what I just said to enable the plugin, but it will also do a bit more, as remote execution isn't the simplest plugin we have. So number one, it will deploy the configuration file for remote execution. Right now, it's completely static besides the one enabled line. At some feature point, we will allow you to edit also like the other parameters here, but you have to start somewhere, right? It also enables Dynflow, or has a configuration for Dynflow. It gets both of those basically will be deployed into its Foreman proxy settings D, as you also know it like from a RPM deployment. But to make a Foreman remote execution work, actually, we also need an SSH key. So you're able to define custom tasks that are to be executed for a specific feature. So in this case, the feature is from remote execution SSH, and it generates an SSH key pair and stores it in a way that the container can consume it. Then it adds -- add feature to our test suite. So actually, the feature is present, and because we like tests, we even have a nice test here. So the one test that we do is we looked at the features are actually enabled on the smart proxy by loading the features endpoint. That is like, it's a nice smoke test, but obviously you want to do something proper. And what we have in our repo today is we have a client machine, and for that client machine, we can go and generate a registration command, and then run a job invocation with run script that runs uptime. And like this step will go and register the machine to the server, and then we can verify that the task actually ran. And by now, I would hope that it's still running. I wanted to say I hope it's done with the whole deployment, but it isn't. So we can go and watch it a bit. And I do hope that we paid enough to the demo gods, because I haven't tested this part at all. So here it's done, and you've seen that it like registered the proxy to the Foreman. And if we now go to our smart proxies list, Magic, they are now 2 proxies by the same host name a bit. So we're cheating, but the one is running pulp itself, and the other is the one that's important for script running. I could show you now that it's working, but like I could register a host. I'm not sure it's actually any different, like looking at it than from normal deployment. So unless anybody disagrees, I'll just skip that part and hope that once my PR is merged, everybody will jump at it and add features to Foreman control. Any questions?
Looks like we are all cleared.
Perfect. And on time.
Yeah, right on time. So thanks, Evgeni. It was great to see it in action. I hope to see more of it. Yeah, and that was all for today's demo. Thank you, everyone, for all the great demos. And the next demo is on April 9th. And yeah, and I don't see any more questions. So thank you for joining, and I hope to see you all next time.
Thanks. Bye-bye.
See you all.